Hey everyone, in this video we're going to learn how to factor completely. So when factoring completely, we start by looking for a greatest common factor, then applying our other factoring techniques until the polynomial can no longer be factored. Essentially, we'll be given a polynomial, and we need to factor it to the simplest possible factors. Now that might just take one factoring technique. It might require us to combine 2 or 3 different factoring techniques to get to those simple factors. The reason I suggest looking for a greatest common factor first is it's easier to look for that greatest common factor before we apply our other factoring techniques, although it can be done at the end, just a little bit more difficult to identify as you start breaking up into smaller factors. So for that reason, I suggest look for your greatest common factor first, and then you're also going to have a simpler polynomial to try to factor further. So the best way to understand factoring completely is to do a bunch of examples, and that's what we'll do in this video. So our directions are simple. Completely factor each of the following polynomials. First up, 4x squared minus 36. So the greatest common factor of these two terms is 4. So we'll factor out a 4. That will leave us with x squared minus 9. And now x squared minus 9 can be factored with the difference of two squares. So we're going to have 4 times x minus 3 times x plus 3. And there we have 4x squared minus 36 completely factored. Next, we have negative 2x squared plus 6x plus 80. Now, in factoring a trinomial, it's much easier if this leading coefficient is positive. So if we look at the terms, the greatest common factor of the 3 terms is 2, but we're going to factor out a negative 2 so that the next step of factoring, if there is one, would be a little simpler. So that's going to leave us with x squared minus 3x minus 40. Okay, so now we have a trinomial, and we need to see if that factors. So let's see. Is there anything that multiplies to negative 40 that adds to negative 3? So let's see. Negative 8 and positive 5. So we have negative 2, x minus 8, times x plus 5. Perfect. Now you could use the grouping technique here as well, if that's what you're more comfortable with. But I think in this example, the leading coefficient, 1, is prime, right? So 1 times negative 40 is negative 40. That value being prime, guess and check is the most efficient way to factor. Completely factor each of the following polynomials. 3x to the 5th plus 3x cubed. So the greatest common factor of these two terms is 3x cubed. That would leave us with x squared plus 1. Now, we can't factor any further than this because x squared plus 1 is not the difference of two squares, it's the sum of two squares. So we've completely factored it. Once we learn factoring completely, all of our directions typically say to completely factor, whether we're just applying one factoring technique or multiple. So that's something to keep in mind. 16 minus x to the 4th. So we have the difference of two squares. So 4 minus x squared times 4 plus x squared. 4 minus x squared can be factored using the difference of two squares again. So we're going to have 2 minus x times 2 plus x times 4 plus x squared. So here we applied the difference of two squares twice in order to completely factor 16 minus x to the 4th. Negative 2x squared minus 3x plus 5. Again, factoring a trinomial with a positive leading coefficient, just a little bit easier. Other than that, I don't see any common factor. So let's factor out a negative 1, and we'd have 2x squared plus 3x minus 5. So we have negative 1. So let's see, the leading coefficient and the constant term are prime, so guess and check should work nicely. So we have 2x and x. And let's see. So we need factors of 5 or 5 and 1. So we need to think of how to place 5 and 1 so that we would get positive 3x when we're distributing? Well, let's see. If I do plus 5 here and minus 1 there, I would get a plus 5x minus 2x, which is 3x. Perfect. Now, this doesn't have to be done as a two-step problem. You could have looked at the original trinomial and factored directly from that step. You would have either got negative 2x minus 5 times x minus 1, or 2x plus 5 times negative x plus 1. Those are correct as well, but I find it easier to take the greatest common factor of negative 1 out, and the trinomial is just a little simpler to factor. X cubed plus 2x squared minus 25x minus 50. So we have 4 terms, so the only technique that we know would be grouping, so let's see if grouping would work. So we'll group the first 2 terms together, we'll group the second 2 terms together, make sure I put that addition sign in there. The greatest common factor of the first 2 terms is x squared, and then we have x plus 2, plus we can factor out a negative 25, and that would leave us with x plus 2. Greatest common factor of x plus 2 leaves us with x squared minus 25, but x squared minus 25 can be factored using the difference of 2 squares, so we have x plus 2 times x minus 5 times x plus 5. And we've completely factored x cubed plus 2x squared minus 25x minus 50. Next up, 15x cubed minus 85x squared minus 30x. So we can factor out a 5x, and that's going to leave us 3x squared minus 17x minus 6. Okay, so we have 5x. So in this case, I will use the grouping technique just to show it, although don't think it's necessary because we do have 3x squared here. But just as a reminder of our technique, we're going to do 3 times negative 6, and that's negative 18. So we need to think of a factor pair of negative 18 that sums to negative 17. So negative 18 and 1. So we'll rewrite the trinomial with 4 terms, 3x squared minus 18x plus x minus 6. We'll group the first 2 terms together, the second 2 terms together. So we have, don't forget about the 5x. We do have to bring that along at each step. So we'll factor out a 3x, then we'll be left with x minus 6. Factor out a positive 1. I know that's a little weird, but we want to write it as the product of 2 terms. X minus 6 is the greatest common factor. So we have 5x times x minus 6 times 3x plus 1. And as another reminder, I know I've said this throughout all of the factoring videos, you can always check your answer by distributing everything back out. As long as you don't make a simple mistake, you should get exactly the polynomial you started with. Next up, 2x squared y minus 4xy plus 12y. So looking at it, greatest common factor of 2y, that would leave us with x squared minus 2x plus 6. X squared minus 2x plus 6. So are there any factors of 6 that add to negative 2? So not that I can think of, but we always can check, right? The discriminant I should have another n in there, discriminant. And if you forgot what that is, that's b squared minus 4ac. Right, so just checking that out. So a is 1, b is negative 2, c is 6. So what's our discriminant going to be? So b squared, so that's negative 2 squared minus 4 times 1 times 6. So that's 4, it's a weird looking 4 4 minus 24, which is negative 20. Not a perfect square, so we know that this quadratic is not factorable, if we want to be really sure. Next up, negative 9x cubed plus 9x squared minus 81x plus 81. So the first thing, we'll take a greatest common factor of, let's take the negative out too with the 9. So we have a positive leading coefficient. So we factor out a negative 9. That's going to be x cubed minus x squared plus 9x minus 9. Now we have a 4-term polynomial, so if it's going to be factorable, it's going to be with grouping. So let's try group the first 2 terms together, second 2 terms together. So we have negative 9. Greatest common factor of these terms is x squared, leaves us with x minus 1. Greatest common factor of these 2 terms is 9, and then x minus 1. So we have negative 9. Inside, x minus 1 is the greatest common factor, so we can factor out an x minus 1, and we'd be left with x squared plus 9. X squared plus 9 cannot be factored any further, so we are done. X to the fourth minus 13x squared plus 36. So this is interesting. We've never really seen a trinomial where the exponents are to the fourth and to the second, but let's see if we can just use our typical trinomial factoring approach and make an adjustment so that when we multiply our factors out, we get x to the fourth as our leading term and x squared as our middle term. So let's just try to factor this as a normal trinomial. Leading coefficient of 1, so I don't need to multiply it out. Okay, so we have 1 times 36, so we need factors of 36 that add to negative 13. So let's see, 9 and 4 add to 13, so if they're both negative, still multiply to positive 36, and they would add to negative 13. So let's see, x squared minus 9 and x squared minus 4. Now let's just make sure that works. I'm going to write out my work and then erase it. So if we distributed this out, we'd have x to the fourth, and then minus 4x squared, minus 9x squared, plus 36. So x to the fourth minus 13x squared plus 36. Okay, so perfect. Those factors are correct. So then we can keep factoring. X squared minus 9 can be factored with the difference of 2 squares, so x minus 3 times x plus 3. And x squared minus 4 can be factored as x minus 2 times x plus 2. So this is an interesting one because we've never really seen a problem like this, but we can use our trinomial factoring technique to make an adjustment. Now, we saw if we distribute it out, we do get this. In general, rule of thumb, right, we have x to the fourth, so we'd factor with x squared. So those middle terms are going to have x squared in them. And we are trying to get an x squared. Right? If this was x cubed, we'd have an issue because we'd have these x squared terms, and that wouldn't be equivalent to x cubed, if that makes sense. Right? You can play around with different factors. You can try, if you thought about it differently, try it out. Multiply it and see why it does or doesn't work. Okay. 7x squared y squared minus 7y to the fourth. So greatest common factor here is 7y squared. That leaves us with x squared minus y squared. X squared minus y squared can be factored using the difference of 2 squares. So we have x minus y times x plus y. And again, don't forget about that greatest common factor and to bring it down in each line of your factoring. Okay, don't leave it off and think you're going to remember to put it back in the final answer. Typically, we forget. 3x cubed y plus 36x squared y plus 108xy. So looking for a greatest common factor, that's going to be 3xy. And if we take that out, we'll be left with x squared plus 12x plus 36 So now 1 times 36 is 36. So we need factors of 36 that are going to add to 12. Well, that's going to be 6 and 6. So our two factors here are going to be x plus 6 and x plus 6. If we wanted to condense it, we could write this as 3xy times x plus 6 squared. Either of these factoring is correct. Negative 6x cubed plus x squared plus 12x. So greatest common factor is x, but let's take out a negative x, so that leading term is positive. So we'll factor out negative x. That leaves us with 6 x squared, that's better, minus x minus 12. Okay, so the leading term and the constant are both not prime. So let's use our grouping technique. So 6 times negative 12 is negative 72. So we need factors of negative 72 that add to negative 1. Okay, so the first factors that come to mind that are really close for 72 are 9 and 8. Well, let's see, if I make 9 negative and 8 positive, that would give me negative x when we distribute. Okay, so that works. So we'll rewrite our trinomial with 4 terms now, so 6x squared minus 9x plus 8x minus 12. We can group the first two terms together, second two terms together. So we have negative x times the GCF of the first two terms is going to be 3x. That will leave us with 2x minus 3. GCF of the second two terms is 4. That leaves us with 2x minus 3, which is perfect because now each term has a greatest common factor of 2x minus 3. So we factor out 2x minus 3 and 3x plus 4. Again, don't forget about that negative x in each line. Last question, x to the 6th minus 80x to the 4th minus 81x squared. So the greatest common factor is x squared. That leaves us with x to the 4th minus 80x squared minus 81. So we factored a trinomial similar to this earlier in the video. So 1 times negative 81 is negative 81. So we can go directly to our factors. So instead of x and x squared and x squared, so that we multiply, get x to the 4th. And let's see. So factors of negative 81 that add to negative 80. So that would be negative 81 and plus 1. Now, x squared minus 81 can be factored with the difference of two squares, so x minus 9, x plus 9, times the x squared that we factored out, times x squared plus 1, which is not the difference of two squares, so that stays as x squared plus 1. So again, we basically practice with all of our factoring techniques in factoring completely. We want to look for a greatest common factor first to try to simplify the problem, and then see, can we apply one of our other factoring techniques? With all factoring problems, we can always distribute out our factors to see that we do indeed get the original problem. But with that, the only way to get better at factoring completely is for you to do more on your own. So, head over and get those practice problems done. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.